Hello once again and welcome to economics class. And of course today we're going to continue on our study of the theory of production. Today we're looking at the production function, and then we'll look at also short run and long run. Look at comparison between both. Okay, but rest assured that if at the end of this class, all right, any question that has to do with production function, short run and long run, okay, which are abundant, okay, in your questions, in your past questions, all right, you'll be able to answer all of them confidently, all right. So do not forget that this tutorial is brought to you by the O3 Schools JAMB CBT practice application. It is all you need to succeed in your exam. Say you want to pass your JAMB exam at once, please get the app. Our testimonies are there to show for it, okay? All right, so please start early, get the app. We'll talk about the features of the app. Let us see a JAMB pass question from the O3 Schools app. This is a 2012 question number 24. It is being displayed on your screen right now. It says that if a firm doubles all inputs in the long run, and the total output is less than doubled, this results in A says diminishing returns, B says constant returns to scale, C says increasing returns to scale, D says decreasing returns to scale. Okay, so we'll be back to this question and many more at the end of the class and not before, because at O3 Schools we pride ourselves in giving you value first, which many other people do not do. Let us teach you. After we have taught you, every other thing will become easy for you. Answering questions will be the easiest. Okay, it will not be a problem for you at all. All right, so please ensure you download the application from Play Store. The app has all you need to succeed in your examination. It has all the past questions that you need for your exam, okay, with some other interesting features like the classroom feature. The classroom feature has lecture notes. The lecture notes, they are planned according to your JAMB syllabus. There's also a study plan in that classroom where you can create a timetable for yourself to study so that you can finish your syllabus in time. All right, there's also the question search feature. Just like the way we search for this question now, we just went to the app, went to economics, search for what? Production, the theory of production, and questions under it come out. Or just search for production function, or search for long run production, or short-run production. Okay, the questions under it that JAMB has set from previous past questions from previous years will come out to you to answer. A very important tool to your success. Then, of course, there's a UTME mock challenge. Okay, we test you every Saturday to see how prepared you are for the exam. Okay, apart from preparation, you get used to JAMB past question, JAMB likely exam question. You familiarize yourself with how JAMB set questions, thereby building your confidence towards the main examination. Activation of this app is less than the price of rice and chicken in a good restaurant. So please do not value rice and chicken over your success. Get the app, start immediately, start early, all right? And you see how well you have done or how good you have done yourself. So let us see production function, all right? So we'll say here on the board that production function is a mathematical expression, okay? It is a mathematical expression or equation that describes how inputs are transformed into outputs. Okay, it is a mathematical expression or equation that shows or that describes how input. Okay, you put what input and then you get output, isn't it? How inputs are transformed into what output. You can also define a production function, or you could say rather that a production function shows the relationship between what inputs, okay, and what an output. Okay, it shows the relationship between input and output in the production process or in a production process. Okay, relationship. You can also say that the production function, okay, shows what the relationship shows. If you want to write, please write down. Shows the relationship between inputs, okay, and what? And outputs, okay, in a production process. Okay, so this is another way of defining what production function. Okay, so basically the production function tells us how much output, okay, how much output you can get when we put in what a certain number of inputs. Okay, it tells us how much output, okay, that can be produced, how much output that can be produced by using different quantities of what, of input, by using different quantity of input. How much output can we get? If you put in what this marker now, okay, I'm going to get 10 markers. Okay, if you put in what one rubber of gari, I'm going to get 10 rubbers of gari. If you put in 1 spoon of milk, I'm going to get 10 spoons of what? Of milk. Okay, or if we set trap, okay, I'm just giving you hypothetical examples. Okay, if you set trap with 1 monkey, okay, so, or with 1 fish, maybe we'll get 10 rats to kill. Okay, the input and what, the output, the relationship between them in the production process is what we call what, a production what, function. Okay, and the general form of a production function is what, is Q is equals to Q. We say it's a function of, okay, it's a function of, okay, this F is a function of, okay, L T, or let me say L K T E, okay, where what, Q means output. This Q here means output, okay? So Q means output. This is the general form, okay, of a production function. That Q is a function of LKTE. I'll tell you what LKT and E mean here, okay? They signify the factors of production, okay? So F is a function of, it shows us what, our input, or how can produce what, output from input, or our input produces what, output. Okay, function of F here means what? Function of. Whenever I say function of mathematics, okay, it means here that what, that it means what, how inputs, okay, produce outputs. Okay, that's what function of means there. Okay, of course, L here, L means what? Land. All right, please take note of that. K there means what? Capital. Okay, then what? T there, sorry, L means labor. Sorry, M means labor. Sorry, labor. K means what? Capital. T is what? Land. T means land. And then what? E is entrepreneur. Okay, so that is that for that. This is a production function. This is the general form of a production function. That Q is a function of what? Labor, capital, land, and entrepreneur, okay, the factors of production. But if a factory, for example, uses only what? Labor and what? And capital, okay, the production function will now be what? Q. If a factory uses only labor and capital, okay, the production function will now be Q. We'll say Q is a function of what? Labor, then and what? Capital, okay. This will now be the production what? Function, okay. So suppose, for example, I tell you that what? That I give you a production function and I say Q, okay, is equals to what? Let me say 5L plus 2K. Okay, if I give you this kind of production function, what does it mean? Or what does it what signify? This means here that each unit of labor, okay, this means here that for L means labor, isn't it? K means capital. So what this signifies, or how you can translate this to someone, is by saying that what? That each unit of labor, okay, each unit of labor, okay, adds or produces what? 5 units of output. Okay, that's what it means. It means that what? Each unit of labor, okay, adds 5 units of what? Of output. Okay, and then what does it mean here for the 2K? It also means that what? Each unit now of capital, okay, adds what? 2 units of what? Of output. Okay, this is what it means. This is how you can interpret it. All right, so this is a production function for a factory which only uses what? Labor and what? Capital. All right, so now you could say this could be for the short run, basically. All right, because labor and capital, all right, we can vary labor, okay, but you cannot what? Vary capital. Capital is fixed for in the short run. Okay, sorry, we'll talk about short run and long run. Let me not get ahead of myself now. Okay, so Q is a function of 5L plus 2K. L is labor, K is capital. It means that each unit of labor gives us what? 5 units of what? Of output. 5 units of output. While each unit of capital gives us what? 2 units of what? Of what? Of output. Is how we interpret it. All right. So now what are the key characteristics of the production function? What does the production function tell us? What does the production function show us? Okay, let us quickly see the key characteristics of the production function. Okay, the production function, like we have said, it shows input to output relationship. Okay, relationship between the input, what you are giving to the system, and what you are getting back. So it shows the relationship between input and output. All right, so that will be one of the first characteristics we'll look at. Let me take this off. All right, so number one, the first characteristic we look at for here is 1. All right, it shows what? Input, output relationship. Okay, please take note of that. All right, so this is one of the key characteristics of the production function. Then number 2, note that production function can be what? It can be short run. Okay, number 2, it can be what? Short run. Okay, for short run, okay, some variables are what? Are fixed, while some are what? Some inputs are fixed, while some are what? Are variable. All right, take note of that. Okay, so in the short run, some inputs are fixed. Usually, the ones that are fixed, usually what? Capital, whilst other can be varied. That is what labor. So we'll talk about short run and long run production. We'll explain better and you will get better. All right, you understand. If you now come back to this to even watch itself, you understand far better. Okay, so let us see. It can be short run. Okay, with some inputs, with some inputs fixed. Okay, or long run. Okay, it can either be short run or long run. In the long run, okay, all what inputs are variable. We'll get to it very soon. Okay, all inputs variable. Okay, so that is another key characteristics of the production function. Then also, it also helps firms. Okay, it helps firms to allocate resources. It helps firms to allocate resources. Okay, so that is another key characteristics. Number 3, it helps firms to decide how to allocate resources. Okay, that's another key characteristic of the production function. Okay, and also another key characteristic that it forms the basis for some economic concepts. Okay, it forms the basis for some economic concepts like marginal product, cost analysis. Okay, and of course, long run scale. Okay, let's quickly see. Number 4, we say that it forms the basis for concepts like marginal product, okay, returns to scale, and of course, costs analysis. Okay, so all of this we are going to see what they all mean. Marginal product, return to scale, cost analysis. We'll see what they all mean later on. Okay, in full or details. But for now, I'll just tell you briefly what they mean. Okay, in case maybe we're not able to do that. Okay, so now marginal product. What is marginal product? Of course, we know it is an economic concept. Okay, marginal product. Marginal product, okay, refers, like we said, it's an economic concept. Okay, it refers to an additional or to the additional output produced. Okay, refers to the additional output produced, okay, when 1 unit of a variable input, like what? Like labor, okay? Like labor is added, okay? While keeping all other inputs constant, while keeping all other inputs constant. All right, so I will explain this so that you understand. you have 10 workers in the field, okay? You're producing 2 bags of rice every day, okay? So that you are able to harvest 2 bags of rice every day. Now, eventually, you now add another unit, okay, of labor. All right, let's say you now add let's say 1 more person to it. You now have 11 people, okay, working on the farm to produce, to harvest the rice. I'm able to harvest what 3 bags, okay? You see, that is, you have an additional output. Okay, so that's what marginal product is about. Just like we'll talk about marginal utility. Okay, the satisfaction you are getting. Okay, from adding. Okay, from taking off or consuming another slice of pizza. Okay, that's why what marginal product is also what looked or likened to. Okay, so marginal product refers to the additional output that is produced when 1 unit of a variable input like labor is added while keeping all other inputs constant. Okay, so we'll talk more about it when we get to that aspect. Okay, so like we said, it forms what the basis. Production function form the basis for what, for some economic concept like marginal product. Also returns to scale. Let's quickly see what returns to scale is all about. All right, that will be very, very easy. You will enjoy it. You will enjoy returns to scale. All right. I'm not even sure I'm supposed to be talking about all of this now, but let me just do it. I don't know if we'll be able to do a full class on it. All right. So let me throw some light on it. Okay. Returns to scale. Returns to scale. Okay. It's another economic concept that describes. Okay. Return to scale describes, or it's a concept that describes, okay, how output changes. How output changes when all inputs are what? Increased by the same proportion in the long run. Okay, so return to scale describes how output changes. Okay, how the output of what a production process changes when all inputs are increased by the same what proportion in the long run. I know that in the long run, all inputs are what? Are variable. All right. So that is return to scale. Okay. It describes how output changes when all inputs are increased by the same proportion in the long run. And in the long run, remember that what? All inputs are what? Variable. The basic idea is that if you double all inputs, okay, for example, like labor and capital, okay, what will happen, okay, to the what? To the output. Okay, if you double all inputs, what will happen to what? To the output. Okay, so let's quickly see what will happen when we double all inputs. But before that, remember that we have 3 types of returns to scale. Okay, take note. We have 3 types of returns to scale. Number 1, we have increasing returns to scale. Okay, we also have what we call constant returns to scale, and then lastly we have what we call decreasing returns to scale. Okay, so let's quickly now see what will happen to the output. Okay, when we double all inputs. All right, so now depending on the type of return to scale, that's how we're able to know whether it's increasing, whether it's constant, or whether it's it is decreasing. Let us quickly see that now. All right, so let's say we have our, let's use the tabular form to quickly explain it. Okay, so depending on the type, let's say this is type. Okay, we have for example, increasing. Okay, then here we have constant. Then here we have decreasing. All right, here we have decreasing. Okay, so what will happen when all inputs are doubled? Okay, this is the type. What will happen if all inputs are doubled? Okay, so type, what will happen if all inputs are doubled? And then let us give example. Okay, an example of it. Okay, so like I've said earlier, that the basic idea of return to scale is what will happen to output when inputs are doubled. Okay, let's say an input like labor and capital is double. What will happen to the output? That is the basic idea. All right, so for the increasing returns to scale, okay, let's say what to say now? Let's say input more than doubles. Okay, that's why it's called increasing. Okay, we're using what double. Okay, but let's say it's more than doubles. When you mean more than double, more than times two, isn't it? Okay, so what will now happen? An example, for example, an example will be that what? Let us give an example here. Let's say input, okay, more than doubles. Okay, then output. You see that what output will what? Will triples. Okay, will triple. All right. Output also will more than double. Okay, what will happen to output when input doubles? Output will what? Will double too. Okay, but it is not under increasing what return to scale. Okay, it will be under constant return to scale. Okay, now but if output in the increasing return to scale, if input more than doubles, it doubles more than times two. Okay, it increased rather more than times two. All right, that means that the output will also increase more than what? Times two. That's why we're saying here that what? An example is that as input more than doubles, output will what? Will triple, which is more than times two times, isn't it? Now, let us now give an example for constant return to scale. Okay, if input exactly doubles, exactly what? Doubles. Okay, exactly. That's an example of constant return to scale. If it exactly doubles, what would happen? Then, of course, input or output will what? Will also what? Will double. Okay, because it's constant, all right? It double here, it will double here. Okay, because it is increasing, if it more than doubles, then this one will also what? More than. The output will also more than double. Okay, then for decreasing, what about if input less than doubles? Okay, if input less than doubles, that means that what? Output will what? Will increase by what? 1.5 what? X. Okay, or by 1.5, less than 2, isn't it? Because it is decreasing. Okay, so we're not giving an hypothetical what value. All right, so if it's more than doubles for increasing return to scale, then input will what? Will more than, sorry, output will what? Will more than double. That's why I'm using times 3 here. Okay, but for the constant, if input exactly doubles, output will also double. For decreasing, as input is less than doubling, then output will also what? Less than double, which will be less than times 2, which is now 1.5. Very simple. So a real life example here would be, for example, let us say a factory uses what? Labor and machine to make shoes. All right. We know what this one is now, short run, long run. Let's say a factory uses what? Okay, labor and machines to make what? Shoes. To make shoes. Okay, so it's a factory that what? Produces shoes. All right. Now, if you double labor and machines, okay, you increase number of laborers and also increase number of machines. Okay, and then you now get 3 times the number of shoes you were making before without doubling it. Okay, you see that is an example of what? Of increasing return to scale. I hope it's very clear. Now, if, for example, it gives you exactly 2 times, what? The number of shoes you were making before, that would be an example for constant return to scale. But for example, if it gives you what? 1.5, that is less than times 2. That's now an example of what now? An example of what now? Of decreasing returns to scale. Very easy. I'm sure by now you understand fully what returns to scale what means. Okay? Then of course, cost analysis. We will talk about cost analysis in another time. Okay, we have taken so much time discussing marginal products and and returns to scale. Now let us quickly see short run and long run. Short run and long run. Short run and long run. Okay, so we'll say here that the short run is a time period during which at least one factor of production is fixed. Okay, that is short run. All right, we say that the short run is a time period during which, in fact, let me just make this easy for you so that you understand very well and perfectly. And before we do this, I've seen that a lot of you do not support us. Okay, something as common as subscribing to this channel, which is free, by the way. Subscribing to the channel is free. just click on that red subscribe button. If you have done that before, no problem. And it helps you because you get notification whenever I release a new video. Okay, I don't know why you are not subscribing. You don't like our videos, you don't comment, you don't share. That is not in any way to help us. Please help us, like, share, comment, okay? And of course, keep sharing. And then subscribe to our channel to make us grow, all right? So please, let us continue. We said in the short run, in fact, I said I wanted to make it easy for you, all right? So think of short run like you were hired to manage a factory, okay? Think of short run like you were hired to manage a factory. The factory is already there. The machine is already there, all right? So as you are coming to the factory, all right, you do not have a choice. Okay, it is what is available that you work with. You cannot say you want to increase the size of the machines there, or you want to buy new machines. It is machines that are there that you'll be using. That is in the short run. Think of short run like days, like hours, days, months. Okay, all right. That's how you think of a short run, or at most a year. All right, that is short run. Okay, that is short run production. You think of it like hours, like weeks. Okay, like months, or what, at most a year. That is what short run what production. You do not have enough time. So the capital you have is fixed. All right, but of course you can actually increase the number of laborers, so that you can increase productivity, so that you can increase the production process. Okay, but you cannot change any other thing. You cannot say you want to build bigger factory. That this factory that they put to do it too small. I don't feel there for this small factory. Maybe they put me for a big one. You do not have any choice like that in the short run. All right, so it is what you have, you work with. In simple terms, that's what short run means. So it's a time period. Technically, short run is describing a time period during which at least one factor of production is fixed. Okay, and that factor of production that is fixed is capital. Okay, capital is is fixed in the short run. Okay, but you can vary labor. You can vary labor. Okay, you can find new laborers. Okay, you can hire more laborers to come work for you to increase your productivity. Okay, which is usually what capital like buildings or machinery, while others like labor can be varied, isn't it? So that is short run production. Okay, so let's quickly see characteristics of short run. Characteristics or key characteristics of short run. Okay, so for the short run. Okay, like I've said before, that some inputs are fixed. Okay, like what now? Capital is fixed in the short run. Okay, you cannot say, give me big money. I cannot work with this budget where they give me. Okay, that's the short run. Okay, come and see we want to see what you can do first for this period of time, pending when we have enough capital to build a bigger plant. Okay, that is short run. Okay, so some inputs are fixed, which is capital, while others vary, which is like now labor. So you can say, let me hire more laborers so that we can at least produce more. All right, it's as simple as ABC. That is one of the key characteristics of the short run production process. Then of course another one is that firms cannot expand. Okay, number two, this is number one. Then number two, firms cannot expand factory size, but can hire more workers. Okay, which is what we just looked at. Okay, firms cannot expand factory size, but they can hire more workers in the short run. Then of course number three, subject to the law of diminishing returns. Okay, so even as you're hiring more workers, okay, there's a point that you hire worker, and that worker you're hiring, okay, will now become very, very useless. Okay, it will not be added to the production process at all. Okay, so it is subject also to the law of diminishing what returns. Please take note of what of that. All right. So, like I'm saying, basically, as you can hire workers in the short runs to increase productivity, but as the more you hire, it gets to a point that if you keep hiring, okay, those additional units you are adding, okay, will not be leading to productivity again. Okay, so at that point, they become what useless. All right. So that is what another what key characteristics of what of the short run production process. And let me give as an example, let's say in a factory or in a bakery, for example, now in a bakery, all right, you already have what your oven. You already have your oven. You are told to come and manage a bakery, for example. You cannot increase the size of the bakery, okay, but you can easily what hire more workers to come and increase the production of bread, okay. That is an example of the short run what production, okay. The capital is fixed. The bakery is already there. Okay, the kitchen where they bake the bread is already there. You cannot increase the capacity. Okay, but of course you can hire workers to increase productivity. That's an example of the short run. Now let us see long run quickly, and then we'll be flying. Please like the video, share, comment. Okay, share and comment. Okay, so let us look at the long run production process. Long run. So the long run is a time period in which all factors of production are variable. Okay, we talked about that. Okay, land, labor, capital, they are variable. Okay, you can decide to work. So your firms can change plant size. You can try to change the size of the plant or of the machine that you are using for production. You can buy new machinery. You can even enter or leave the industry. Okay, that is what long run production. Okay, so in the long run, you have enough time to say you want to build a new factory. You have enough time to say you want to buy more machines. You have enough time to say you want to do whatever you want to do. Okay, that is the long run. So in the long run, all factors of production are variable. They are variable. The entrepreneur can decide to say he wants to leave or want to he can take a huge business decision to pump more money into the production process. It's his choice. Okay, so that is what the long run. Let us see the key characteristics of the long run. Number one, of course, you know that all inputs, as you can see from here, all inputs are variable. All inputs are variable. Then number two, you know that firms here, okay, they have a lot of time, okay, so they can plan, okay, they can plan. Firms can plan and adjust scale of operation, okay. And of course, remember we talked about returns to scale, okay. So this long run production leads to concepts. It leads to concepts like returns to scale. Okay, so now as a real life example, you are hired to manage a bakery. I'm talking about long run now. So the same bakery we're talking about before, okay, that cannot increase the size of the bakery or the kitchen. They cannot in the long run, they cannot increase the size of the kitchen, hire more workers, even fire workers if they want to fire. Okay, then of course they can even increase the size of the bakery. Okay, they can build new structure, they can do and undo. That is the long run. All inputs of production are variable in the long run. That is the key takeaway. Okay, while in the short run, labor is variable, capital is fixed. Okay, please take note of all of those and you will have peace. Let's quickly jump to the Auto School JAMB app. You will answer all of these questions. Okay, you give me all the answers, the solutions to the answer, or the options, okay, in the comment section. I'll read it out. It will be shown on the screen. Just tell us the answer. This is 2018 number 27. From using the question search feature from the app, 2018 number 27. Okay, we searched for for short run and long run or production function, or search for theory of production. We see questions. Okay, so now they say here that increase in supply due to changes in plant size will take place only if plant size want to change, the machine size want to change. Okay, will it be short run or long run or normal time or market period? Okay, you know the correct answer. Put it in the comment section. Number 2, 2001, number 16. They say the long run is a period during which a firm A says replaces all its inputs. B says sells inputs to purchase fixed assets. C says sources all its inputs from within. D says varies all its input. Okay, so replace, the word replace, okay, and vary, okay, they are not the same. Okay, varies. Okay, so actually varies is the correct answer. So check option, sorry, I don't know what the answer is there. Either replace all its input or varies all its input. Which one did I tell you? Tell me in the comment section. Let me see how good you are following. 2012 number 24. 12 number 24 says that if a firm doubles all inputs in the long run, if a firm doubles all inputs in the long run, double, if a firm doubles, okay, all inputs in the long run, okay, and the total output, but the total output less than doubles, the total output less than doubles, okay, what are we talking about there? Is it diminishing return? Is it constant return to scale? Is it increasing return to scale or decreasing return to scale? So tell me the answer in the comment section. 2005, number 28, it says the technical relationship between input combination and maximum attainable output. The technical relationship between input combination and maximum attainable output is called what? A say production function, B say an indifference curve, C says an isocost, D says an isoquant. Okay, so we'll talk about isoquants very soon. But I bet choose the correct answer and put there. It's looking at you. Then 2001, also have 2001, number 17, says that a production function relates A say wages to profit, B say output to input, C say cost to input, D says cost to output. Okay, so you tell us the answer in the comment section. All right, so thank you for joining us. I'm sure you are liking the video, ensure you are subscribing, ensure you are sharing, and ensure you are studying. Okay, I'll see you in the next class. We'll talk about specialization. Okay, division of labor and specialization. See you there.